This video is on Spearman's rank correlation coefficient. So Spearman's rank correlation coefficient, which we denote with R and a little s, is a measure of the nonlinear correlation between two variables. It shows the extent to which one variable increases or decreases as the other variable increases. A Spearman's rank correlation coefficient value of 1 means the data set is strictly increasing, and a value of -1 means it's strictly decreasing. A value close to 0 suggests that the data is not consistently increasing or decreasing. Data that is only increasing or decreasing is known as monotonic, and Pearson's correlation coefficient is more affected by outliers than Spearman's. So previously we've looked at Pearson's, which is for a linear correlation. Spearman's is for nonlinear. And as we said here, outliers affect Pearson's more. So to calculate the RS value, what we need to do is we need to rank both sets of data in order of magnitude, calculate the Pearson's correlation coefficient between the ranks. So the process of calculating is the same as Pearson's. So you can look at a previous video on the Pearson's correlation to look at how to do that. The only thing that's different with Spearman's is we have to rank the data first. His first example, find Spearman's rank correlation coefficient of the following sets of data. So the first one, we've got time spent training, which is X hours, and time to run 2 kilometers, which is Y minutes. So when we are ranking, we look for the largest value first. So time spent training, the largest value is 45. So we're going to give that a rank of 1 because it's the highest value. It's the highest ranking. And I'm just going to cross that. Then we look for the next highest, which is 34. So that will be of a rank 2. So in my table, where 34 would be, that's where I'm putting a 2. Then we have 29, which would be a 3. Now we have two 23s. So the two 23s here and here would be ranks 4 and 5. Now we can't give them different rank values because they are the same value. So we have to find the middle of them. So because it is 4 and 5, they rank 4 and 5, you do 4 plus 5 divided by 2, which would be 4.5. So we're going to give both of those a rank of 4.5, and that takes a rank of 4 and 5, and then we have the last value, which is 17, so that would be rank 6. Then we do the same with the Y values, so we look for the highest one, which is 14, so that would be 1, 12, the next, which would be 2. We have two 11s. Their ranks 3 and 4, so it would be 3 plus 4 divided by 2, so it would be 3.5, so they will both get 3.5. Then 10 would be 5, and 8 would be 6. Now in your calculator, you put these bits of data into the spreadsheet in your calculator, you go into your stat calculations, linear regression, and then look for the R value, not R squared, but the R value. And then that will tell you the Spearman's rank. So with this one here, you get negative 0.956. Means it is a strong negative correlation. Part B, we're doing exactly the same. So number of pets, 1, 2, 3, 4, 5. So with this one, the highest ranking is the one with the most pets. So the person with 5 would be 1, and you'll just see it goes that way. 1, 2, 3, 4, 5 in the opposite direction. So the highest number of pets we give a rank of 1 because it's the largest. Then same with the bottom, we look for the largest, which is 16, so that gets a 1. Now we've got two 8s, so they will be ranked 2 and 3. So we do 2 plus 3 divided by 2 because there's two numbers, which will give us 2.5 for both of those. Then this would be a 4 and a 5. Work out your R value, and you get a value of 0.975, which is a strong positive correlation. Example 2, I've already done this solution for this, but we'll just talk through it. So a student was asked to rank 9 different makes of burgers in terms of which she liked best to which she liked least. She put number 1 for the one she liked best and 9 for the one she liked least. These rankings and the cost of burgers are given in the table. Explain why you cannot use Pearson's. So in this one, we can't use Pearson's because they've already ranked something, and ranks are given rather than quantifiable data. So with Pearson's, you need quantifiable data, so it needs to be quantities, numbers, and a quantity, so like length, height, distance, time, something that can be measured. B, find Spearman's rank correlation coefficient for the data and comment. So within this, with the taste, we don't actually need to re-rank because they've already been ranked. One's the best, so which would be the highest if we think about it that way, and 9 is the one she likes the least, so she's already ranked that. So then we have to do that with the cost. So the one that costs the most is number 1, and then we work our way down to the one that costs the least, and then you can see I've already done that here. When we work out the Pearson's, you get a value of 0.8, and then we can say that is a strong positive correlation. So we comment on it just like we do with the Pearson's. And that is Spearman's rank correlation coefficient.